Good afternoon, this is Mr. Schweitzer, and this is a quick video on how I go about adding and subtracting using significant figures. Now, one just general idea about adding and subtracting things or combining values of different accuracies. If I were to take a small sample of water, okay, and I have it, let's even say I have it in a beaker, which generally isn't considered to be all that accurate. And I measure out, let's say, some amount of water to be about 50 milliliters, and I'm saying both these numbers are significant. And I take the 50 milliliters and I dump it into a 5-gallon bucket. And at that point, as this bucket may have, I don't know, let's say the bucket's got 5,000 milliliters, and at that point, 500 or 5,000 doesn't really matter. Let's get this cleaned up a little bit. 5,000 milliliters. Then, as I dump this in, I have a very accurate value added to a number that's not so accurate, and therefore we want to take the value that's the least accurate. We want the, we lose our accuracy in the larger inaccurate value. So if I take 5,000 and add it to the 50, how do I go about doing that? Well, just some general addition rules. One, just for sake of clarity, we line up decimals. That's your general addition rule. So I'll take my 5,000 milliliters and line up the 50 to it. So my decimals are lined up. Then number two, I'd say, okay, well, at this point, determine where your accuracy ends. So for the top one, I might say, okay, this guy ends actually right here. And the last one, as I mentioned, being the 5 and the 0 being significant, and happens to end right here. Well, the next step, I would just tell students, okay, just plug in your calculator. And at this point, we're going to get, if we're adding them together, I get 5, 0, 5, 0, decimal, okay. If there are more zeros, keep going. But I have 5,050. What I basically do is when I reach my first rounding line, everything to my left I know, everything to my right I don't know. So 5 plus nothing is 5, and that's a good 5. Something right here plus nothing is still something, so I can't say 0 for certain. So that's why this line here doesn't get used, but the first line is the one I'm using, and everything to the right of it essentially is no good. Alright, what I will use though is that if this number right here is 5 or greater, then I would kick this up, because if this happens to be a 5, if we go 50, 500 milliliters plus 50, and we lose accuracy, I'm going to change that here. Let's take it to keep that 5,000, and we'll add it to this thing, 500 milliliters. Then when I add this one together, I get 0055. Again, my accuracy still cuts off right here. But that 5 is able to round that up to 6,000 milliliters. So in this case, we're taking our chances. 5 plus something will be big enough to round it up to a 6. We're going to take our chances and say yes. In this case, it's going to be something plus nothing is, so we just say it's not big enough, so let's leave it alone, and this number will be reduced to 5000 decimal. Again, I lose accuracy after the 5, so nothing beyond that point can be listed. If I listed it as 5,050, the viewer would assume that's a good 5. But in reality, it's 5 plus something. We don't know what that something is, so we can't list it. and occasionally get some nice little debates with students over what's significant and what isn't. Okay, so this what I basically do, step 4, is I would add my rounding line. Okay, that's what I call this line right here, and then at that point I would simply round to my answer. Alright, so let's try a couple of examples here. I have 125 and 4.00. Now, as I mentioned in a previous video, one of the rules we use here is that no decimal means it's an exact value. So exactly 125, which means this thing continues on. It happens to be an exact value, infinite number of sig figs. So this is my least accurate value, and it will set the accuracy right here. And I am subtracting, so it's going to be 121.00, and this is my answer. Generally speaking, the answer to the left of my round line is what I need. There's no number here big enough to round it up, so I just stay where it's at. 125 decimal, okay, that's ending right there. 4.00. Now, in this case, this one loses actually right here, and this one loses right here. So I'm only going to use the first one, because as soon as I lose actually for one of the numbers, all bets are off. This is going to be subtracting 12100. Again, this number is going to be just this guy, 121 decimal, versus 121 with 0.00. There is a significant difference between this number and that number. Okay, level of accuracy is very important. All right, letter C, 500. Okay, and plus 55. Okay, in this case, the top number loses actually first right here. This is an estimate of 500, which means the 5 is known, but the zeros are just placeholders showing where the decimal place is. So at this point, plug in your calculator, 555, and this 5 is big enough to round up, and I get 600 as my answer. This guy, 1.4e the second, that's, take it out of scientific notation, 1400, move my decimal point over 2 spots, that's 140.0. Add into this thing 0.95. Okay, top number loses actually right here. Add together, I get 140.95. The 5 rounds this up, and we're going to get 140. That 9 is going to kick it up, and it's going to be 141.0. Alright, and this is my answer. One more little example. Let's do 200 decimal minus, let's go with 10. Okay, decimal. They both lose. Well, this one loses actually right here. This guy loses right here. So I'm going to go with the first one and subtract. Okay, so 200 minus 10. Plug it in, I get 190 decimal. Again, that 9 is not big enough to round it up, and I get my answer of 200 decimal. Of course, someone might argue, okay, you're of 200. You know, you're taking 10 away, and you have the same number. Well, it's because our accuracy is not big enough or good enough to see the subtraction of a small 10, a small inaccurate 10. Alright, so these are some general rules. We're adding and subtracting involving significant digits. Thank you very much.